So our CLO for these notes are that students will be able to solve in writing for x using quadratics, vertex form, and completing the square, as well as the following language: if-then statements, quadratic, isolate, vertex form, and completing the square. So in your own words, explain what you think we're going to learn in this lesson. All right, so to start with the vocabulary, remember quadratic means we're talking about equations where x squareds are the biggest exponent. And then for the rest of the vocabulary, the word isolate means to get alone. And to remember when we're solving for x, another way to think about it is we're isolating x because we're getting it alone. Inverse is how we eliminate things or how we get rid of them. And then vertex form was a specific type of quadratic form that looks something like this. So specifically, vertex form has a parentheses being squared, and there's usually some number after it that you add or subtract to the end. So this is vertex form. Remember, f of x just means y, but it's more proper to write f of x. So we do. And whenever they want you to solve for x from vertex form, this is just like the 2 notes ago. So basically what you do, equals f of x, we write equals 0. And we solve it as if it equaled 0. So what's my first step to solve for x? All of this is in a parentheses getting squared. So we can't touch that yet because we have to get rid of this minus 20. And to undo minusing 20, I'm going to add 20 to both sides. So I get 0 plus 20 is 20 equals 5 being squared. And then negative 20 plus 20 is 0. They eliminated, so I don't have to write anything. So my next step to solve for x is to do what? I have to get rid of this squared that's trapping this in a parentheses. So to get rid of squared, I do the square roots. So square root and squared eliminate. Therefore, my answer becomes the square root of 20 equals x plus 5. The square root of 20 equals all of this, 4 points, and there's a long decimal. When there's decimals, usually 2 is enough. So 4.47 would be enough. So I could say 4.47. However, it's important to remember that if this is a plus, the positive version and the negative version equals x plus 5. Or I could also say that 20 breaks apart into 2 times 10, and 10 breaks apart into 2 times 5, and 5 is a prime number. And then the 2 2's would come out front instead. And so I could simplify the square root of 20 to 2 root 5. And that would also equal x plus 5. And don't forget, if I put in here and did 2 square root 5, it's still 4.47. It's just, this is called, the name of this version is called radical form because you're leaving it as a radical, you're just simplifying it. Versus here, this is like the decimal answer. So I still haven't solved for x because x isn't alone, there's still plus 5. And to finish isolating x, what do I need to do? What the minus 5? I'm going to do it to this one too, so you can see the answer in both forms. So for this way, if I'm using the decimal, here's the important thing. I have two answers. I have positive 4.47 that I'm minusing 5 from, and I have negative 4.47 that I'm minusing 5 from because of the plus minus. So I have to remember that I have both answers now, and both answers will equal x. So in this case, x will have two answers. And actually, when you solve for x with quadratics, you will always have two answers. So if I do 4.47 and I minus 5, I get negative 0.53. For this one, if this was a negative, then the answer is negative 9.47. Negative 9.47. So those would be my two answers if I did it in decimal form. If I chose to come over and do it in radical form, the only difference is this minus 5, I can't subtract from this because this is a radical and this one's not. So I would just put minus 5 in the front. And then I do my plus minus symbol and then 2 root 5. And that's what x would equal. I could write them separately with one with the plus sign and one with the minus sign. But I don't have to because I'm doing radical form. Versus when I do decimal form with decimals, I do have to do them separately. One with the positive, one with the negative, so that I get my two different answers. Here, this is two different answers, but because I'm not doing the decimal version, you can write it as a one like this. So which form should you do? If they do not tell you to do radical form, do decimal form. Like decimal is the more normal one. But sometimes the test will tell you leave your answer in radical form. So then you're going to want to leave it like this. All right, so for this example, if they said solve for x, this time it doesn't equal f of x like the one before it did, so I don't have to put a 0 there. But also note that this one here, the one that should be the k, it's not on this side of the equal sign over here. So if I was writing it properly, I would have had to minus the 50 over and do minus 50 equals 0 to write it in proper vertex form. However, when I solve for x, my first step would be to add that 50 over. So why move it over here when it could have just stayed over here? This one, when it's given to you like this, it's actually already done the first step for you, where it moved the 50 over here. So now you just have to keep solving for x. So what's my next step in solving for the x? The whole parentheses is getting multiplied to this 2. So I have to divide that 2 away. Cancels. So then I'm left with just x minus 1 being squared now. Equals, and 50 divided by 2 is 25. My next step in solving for x. To undo the squared, I have to square root both sides. So the squared and the square root cancel each other. So now I'm just left with x minus 1 equaling square root of 25 is 5. But don't forget, it's also negative 5. So it's 5 and -5. So finally, to finish isolating x, what's the next thing I do? To get rid of the -1, I have to add 1. And remember, I have to do it to both my answers now that I have 2 answers. So my answer is x, and then these 2 eliminated, equals 5 plus 1 is 6, and -5 plus 1 is -4. So those are the 2 answers when I solve for x with quadratics, when they're in vertex form. So what if they don't start in vertex form? Well, I'm going to teach you in future lessons how to solve from x from all of the forms, but it's important that you can always convert into vertex form. So remember, if we start in standard form to go to vertex, we have to do something called completing the square, which I'm going to teach you how to do next. So if I start in standard form, and then if I start in factored form, first I have to go to standard by doing something called distributing. Then I have to go to vertex by completing the square. So we're going to practice each one of these. So this one is in standard form right now. And then these are the steps for completing the square. This is how you change it. Step 1, move C away from the other 2. This is a really easy step. Where I'm going to move C away all the way over here. I'm not going to think about C for a second. Step 2 is turn the first 2 into, and it always ends up looking like this. This first part's going to turn into just an x, not an x squared. And then plus or minus, but whatever, this one's a positive, so this one's going to be positive. And then you do half of what this b is. So to write that, I'm going to say you're going to take that b and you're going to divide it by 2. You're going to cut it in half. Then you're going to take this parentheses and square it. So that I'm changing this each time into this. So x changes to x squared, changes to just x. 6x will cut in half. So when I do that, in my example, of x plus, and then when I cut 6 in half, what's half of 6? 3. And then I close my parentheses and square it. And then I'm still not going to think about this -1 for just a second. It's still going to be set aside. So step 3, we have to figure out what we're secretly adding. Because here's the thing, it's not like I'm trying to change my equation. It still needs to be this at the end. Like if I change it back, it still needs to be the exact same equation. So that means that this needs to be the exact same as this. However, it's not. It's not quite the exact same. Let me show you why. When I take x plus 3 and I square it, that means I need to do x plus 3 and times it to itself. And this process is called distribution. So I showed you once before that you can do it by multiplying, where you take this one and multiply it to both of those. And then you draw arrows and you take this one and multiply it to both of those as well. And that's called the arrow method. There's another method called the box method. And it's the exact same thing, it just looks different. So you take a box, and on top you write one of them. So this x might go here, for example. And then this plus 3 goes right beside it right here. Then this x, let's say this one goes on the side. So this x is going to go right here. Then the plus 3 part's going to go right here. Then inside the boxes, you multiply. So like this x is right here, and it's going to multiply to both of these by multiplying to both of these right here. So this box means I do this x, this first x times that x, and x times x is x squared. Then this x times this 3 goes in this box here, and that's 3x. So now I took this x and I multiplied it to both of those right here. Now I'm going to take the 3 and multiply it to both of those. So when I do the 3 times the x, I get 3x. And then when I do the 3 times the 3, I get 9. So now when I write it as an answer, I just have to take all of my inside boxes, and that's my answer, but I have to combine any like terms. So this is the only x squared I have. But then for x's, here's 3, and here's 3 more, so that's 6 x's. So far, this part here is x squared plus 6x from up here, from the original. However, by turning this into this one isn't only this because it has this 9 here. So by turning this into this one, it's almost the same thing, because this, once I multiply it out and distribute it out, I get the x squared plus the 6x. However, I also get this in plus 9. So because I am secretly adding 9, to keep it balanced, even though I'm secretly adding 9, my next step, step 4, is to subtract what you're secretly adding from your c at the end. So I'm going to take this equation, and I'm going to say, okay, this is almost what I had before, but it's secretly adding 9 once I multiply it out. So I'm going to subtract 9 from over here. Because once I add 9, the minus 9 will keep it balanced. It'll stay the same. So then my final answer is y equals x plus 3 squared minus 10. Because negative 1 minus 9 is negative 10. So now this is the exact same thing as this one. I just completed the square and turned it into vertex form. So, and this is now the vertex form. Here, I'll show you quickly. The first one is x squared plus 6x minus 1. And so that's the graph of that first one. And the second one, if I do x plus 3 squared and then minus 10, look, it's the exact same graph because it went right on top of it. See, there's the purple, there's the black. So it's the exact same graph. It's just now in vertex form. So now that it's in vertex form, yay, I have vertex form. Now I still have to solve for x. So remember, once it's in vertex form, to solve for x, I turn the y into what number? 0. We always make it equal 0 if it doesn't, to solve for x. Now, what's my first step? I have to add the 10. When I add 10, 0 plus 10 is 10. And then we still have x plus 3 being squared. With those 10s eliminated, because negative 10 plus 10 is 0. So now what do I undo next? What's the next step? I get rid of the squared by square rooting both sides. So that'll get rid of my squared. So that my answer The square root of 10 equals x plus 3. So because this one, if I go back up, it just has completing the square, it didn't tell me to do it in radical form. So I'm going to do it in decimal form. The square root of 10 is 3.16 and negative 3.16. That equals x plus 3. So what's my last step in solving for x? I have to minus the 3 away, and I have to do it from all of them. Now my final answer is going to be 3.16 minus 3 is just 0.16, and negative 3.16 minus 3 is negative 6.16 equals x, because this plus 3 minus 3 eliminated and canceled. So those are my answers, my two answers when I solve for x. And remember, with quadratics, if you're solving for x, there is always two answers. You should always have two answers when you solve for x with quadratics. All right, let's do a couple more examples. So this one has a lot of instructions, and we need to make sure we follow all of our instructions. So it says solve for x by first putting it into standard form. So what form is this in right now? It's in factored form, and to go from factored to standard, you have to multiply it out. I could do the box method like I did up here to multiply it out, but this time I'm going to do the arrow method. So I have to do x times x, then x times negative 2. X times x will become x squared. X times the negative 2 is negative 2x. Then I have to do 10 to both, so 10 times x is 10x, and 10 times negative 2 is going to be negative 20. So I had 10x and then negative 20. And then I need to combine like terms. So this is it for x squared. But these two, negative 2x plus 10x, combine. Negative 2 plus 10 is positive 8, and they're x's. And then I still have negative 20. So this is my equation. I could write f of x equals, or I could have written a y equals. So now it's in standard form. I went from factored to standard. Factored form. To standard form. Is what happened right there. So if I scroll back up to my instructions, it says solve for x by first putting it in standard form. I did that. Then completing the square to vertex form. So that's what I have to do now. And so I need to follow my complete the square steps. I'm going to quickly write them out. Step 1, move C away. Step 2, an x squared plus bx into x plus b divided by 2 being squared. Step 3, find out what you're secretly adding. And then step 4, subtract what you're adding secretly away to keep it balanced. Oh, and we're subtracting it away from C. And by it, I mean the equation, to keep the equation balanced. And these are our completing the square steps. So let's take it and let's do each one of them. Step 1, move C away. Goodbye, see? All right. Step 2, turn this part into, and it's going to have a parentheses. The squared won't go here. Half of the x won't be here anymore. Half of 8 is 4. And now I need parentheses to square it. So this is almost going to be this, but let's find out what I'm secretly adding. Once you multiply it out, going to equal x times the x. The first x is going to be an x squared. X times that 4 is going to be a 4x. And this 4 times that x is another 4x. Then the 4 times the 4 is going to become 16. If I combine these two 4x's, I'll get 8x's. So the x squared is right here. The 8x's is right here. But what gets added is this plus 16. So I'm secretly adding 16. So that means I need to take this, and this has a secret plus 16 in it, so I need to minus that 16 away to keep it balanced. Now this is my answer, but 20 minus 16, or negative 20 minus 16, is negative 36. And so now I'm in vertex form. And that's exciting, but I still need to solve for x. So let's go back up to my instructions, see where I'm at. So it says, I did that, then I completed the square into vertex form. And it says, then solve for x. I'll do that. But then it says, leave your answer in the most simplified radical form. And that's important because that means I'm leaving it in the square root. So let's finish this out. So there's a solve for x. But I need to leave in radical form. And that's also really important. So remember, to solve for x, the first step is I have to turn this into what? 0. Now, what's my first step in solving for x? I need to add this negative 36 over to the other side. So you guys will eliminate here, and you'll come over here instead. So 0 plus 36 is 36. Now, how do I undo the squared? I take the square roots because those will cancel. But I have to do it to this side. So now I have that the square root of 36 is going to just equal x plus 4. So now, normally I'd put this in a calculator and get the decimal. However, it says leave it in radical form. So I have to simplify it the long way. So 36, when I divide it by 2, I get 18. Then I'm going to break down 18 by dividing it by 2, and then I get out 9. Then I'm going to try to divide 9 by 2, but I get a decimal. So I try by 3, and I find out that it's 3. So my next step, and it still equals this whole x plus 4 thing. Then my next step, if it's under there twice, I'm going to bring it out front. So there's 2 2's under there that I'm going to bring out front. There's 2 3's under here that I'm going to bring out front. And then now that they're out front, there's nothing under the square root left. So when I put them together, 2 times 3 is just 6. And there is no square root. However, and it's also -6. Because the answer is always positive and negative. So the crazy part about this one is even though they said leave it in radical form, your answer is the same as if you put it in the calculator. Because if you put the square root of 36 in the calculator, you're going to just get out 6. So now to finish out my answer, it says plus 4, and how do I undo adding 4? I'm going to minus 4 from both my answers. So the answer is 6 minus 4 is 2, and -10, because -6 minus 4 is -10, and that's what x equals, because these eliminated. And those are my 2 answers for this one. A lot of work, because to answer this one little question, I had to first distribute into standard form, then I had to complete the square into vertex form, then I still had to solve for x after that. But finally we found our answer. All right, this one says solve for x by completing the square. So you don't have to do the radicals, so you can use, because it doesn't tell you to, so we can use decimals, we can use the calculator. These are the steps for completing the square. So let's do it. So first of all, we're going to move C away. Now we're just going to take this middle part and turn it into this, where it gets put in a parentheses. The squared moves from on the x to the outside of the parentheses. The x goes away from here, and this number cuts in half, so 2 becomes 1. Note the minus sign still stayed minus, because this was a -2, and half of a -2 is a -1. So now I've turned this into this, but I gotta take this and figure out what I'm secretly adding, because x minus 1 times x minus 1 is going to become the x times the x is x squared. So when I do this one, I'm going to show you why completing the square works. Because of this squared, you're always going to do x times an x, which is how you're going to get this x squared, which is why we turn this x squared into just an x, and then we're moving the squared to the outside, so that when we do it, you always end up back with that x squared. Then the next step is I have to do x times -1, but then here, this is, because we're squaring, it's the same number, so it's -1 again times x again. So you always end up with 2 of the same thing, where you have a -1x and a -1x. But because I always end up with 2 of those, it's why we cut this one in half. Because half of this is 1, and 2 ones will give me that 2 when I do it here, because I always end up with 2 of the same one that will combine together into the -2x. Then the last thing we do is you take this -1 and then you times it to that -1. And -1 times -1 becomes +1. And that's the thing we're secretly adding. So then we're going to take our equation from step 2 and say I'm secretly adding 1 by putting this here instead of what was there before. So to undo that, I'm going to -1. So that our final answer, 9 minus 1, becomes 8. So now we're in vertex form. Still need to solve for x. going to solve for x. First of all, I'm going to make it equal what? 0. My next step is to do what? I have to minus this 8 away to eliminate it. So 0 minus 8 is negative 8. And that's going to equal x minus 1 being squared. And then what's my next step? I have to get rid of the x squared by doing what? Taking the square root of both sides, so that will eliminate. So I have the square root of negative 8 equaling x minus 1. Well, if I go to Desmos and I try to type in the square root of negative 8, it's going to say it's undefined. It doesn't have an answer. Well, this takes us back to lesson 2 when we try to take the square root of negatives. You cannot because they're imaginary. So remember, just do positive 8, which is 2.82. Square root of positive 8 is 2.82 and negative 2.82. However, because this is a negative 8, the answer has to have an I at the end, because only the imaginary number times itself becomes negative. So still equals x minus 1. So how am I going to finish up solving for x? I have to get rid of the minus 1, and how am I going to do that? By adding 1, because that will eliminate here, and I have to add 1 to both of these. However, can you add imaginary numbers with real numbers? No, you cannot. So your answer, as weird as this looks, is that you have 2.82i plus 1 and negative 2.82i plus 1. And that's what x equals. So much so that you're allowed, because of the imaginary numbers, to just, because you can't combine them with the plus 1. So it's okay to just write 2 plus minus 2.82i and then the plus 1. Presenting the positive version and the negative version of it. Remember, if they said at the beginning to leave your answer in radical form, then we wouldn't have put the square root of 8 in the calculator. We instead would have broken 8 apart where negative 8 becomes negative 1 times 8, and then 8, then that 8's going to go away and becomes 2 times 4, and then the 4 is going to go away and become 2 times 2, and then the negative 1 is going to go away and become I times I, and then if it's under there twice, it comes out front. So 2 of the 2's can come out front, the I can come out front, and the square root of 2 still in there. And then it would have been the plus and negative version. And then once we're here, we still would have needed to add this 1 over. So then our answer would have had a plus 1 at the end as well. So this would have been the answer if they said leave it in radical form. But they didn't. So instead, we put the square root of 8 into the calculator and add the I at the end to get that answer. All right. So go ahead and use if-then statements in our vocabulary words to explain what you learned how to do in this lesson.